So when we talk about sizing the air conditioning and we talk about going down the road of a load calculation, we do have to assume and we have to agree one thing, and that is the law of heat transfer. So all the law of heat transfer says, we go back to high school or grade school science class, is heat travels hot to cold. That's just what it is in the world. A hot surface is going to give up its heat to whatever is cooler around it. That's the law of heat transfer. So in the summertime, in Sacramento, if we have a 98 degree outside temperature, that heat wants to go to your 75 degree temperature inside, or whatever your temperature is inside that surely is cooler with air conditioning. So if you ever went to your outdoor air conditioner and you put your hand over the top of the fan on a real hot day, that heat coming out of there, that's the heat that you're absolutely absorbing from the house and putting back outside. So all air conditioning does is move heat. At Rayo Cook or whoever, we just move heat around. In the summertime, we move it from inside to outside where we don't care about it, therefore cooling you and maintaining a temperature inside. And in the winter, hot to cold, the 70 degree air in the house wants to go to the 34 degree temperature outside. So whatever leaks out and goes there, we have to replace with either a gas furnace, make the heat and replace that heat, or we use a heat pump to absorb heat from outside and put heat back inside that we need to replace that leaked out. So in the summertime, hot air or hot temperature wants to go to your cooler indoor temperature, and in the winter, your warmer temperature wants to go to the cooler temperature outside. So law of heat transfer is important to understand. So with a load calculation, we know how much heat is going to travel from outside to in using engineering and mathematics. And that's why it's so much more accurate than a rule of thumb assumption, which is square foot per ton. So for instance, we look at this house, this wall, we know what insulation is in this wall based on the building code of the year the house was built. And it's pretty close. It's really close. So how much insulation is in this wall dictates how much heat goes through that wall to your indoor comfort and your temperature. Okay? The windows in this house, we know what type of windows they are and what the ratings are by simply looking at them. So the wall insulation can be put into a software program quickly and easily. The windows can be put in the software program. The color of the roof, a dark roof, of course a dark substance, a dark color is going to absorb much more heat than a lighter substance. That's part of a load calculation, and it takes into consideration the color of your roof. The insulation in your attic, we literally can look at that and know what R value of insulation you have in the attic, and if we can't see it, we can go off of building code, which is usually pretty accurate. The doors of the house, how much heat goes through those doors in the summer and how much heat leaks out of those doors in the winter. That's a given because there's an energy rating on what type of door is installed. The fact that you're either on a slab foundation or you're on a raised foundation, you get into older houses in this area that are on a raised foundation, rarely, in the 70s and 80s, do they have insulation in the floor. That has to be accounted for, and so does a slab or concrete. If your house sits on a concrete foundation, there is no insulation. It's just sitting on concrete. So those are things that are going to really affect what size air conditioner you actually need based on one thing, and that is how much heat is making it into your house. Square foot per ton assumption cannot do that. We can also look at, when we use square foot per ton, let's say for instance this house is your house on one side of the street, and we have all of these windows on the front of the house. We have to agree that a solid wall is going to allow less heat into the house through it than windows. You simply just put your hand on the inside of a wall on a 98-degree day, and then put your hand on the inside of a window on a 98-degree day. Of course, the window is warmer and radiating more heat into the house, which makes us have to put more heat back outside with a bigger air conditioner. So if your house was on one side of the street and you had these windows and you went across the street to the exact same house built by the exact same builder with the exact same everything, and you turned this house into the sun where the windows are getting sun on them, the size of the air conditioner substantially changes due to the cooling load of those windows. So square foot of the house did not change. So then you're left with one choice. Oversize it all the time to try and cover these things that are out there, or recognize the differences of building surfaces and use them to size the air conditioner. So next, what we'll go through is you keep hearing oversizing. What's the big deal? Those are the things that you need to know about when picking an air conditioner. What are the effects of oversizing? And is that something, the things that come with that, is that okay for you? And do you care about that? And we'll go through oversizing in the next video.